Are we working? Okay. Welcome back. Up next is Dan Erez. He's a veteran architect, tech lead, and a conference speaker with a background in startups, enterprises, and AI-powered DevOps. He's here to talk about how we think about app architecture with local first development, where apps run locally with local database and sync only when needed. So please enjoy it.
Hi everyone, and thank you for joining me in this pre-lunch session. I promise I won't mention food in this talk again. My name is Dan Erez, and actually it's my second year at Heapcon, still very exciting. And today I'll introduce you the topic of local first development. I think it will be relevant for a lot of people here. And I'll start by describing the issues and the problems and the reasons that I wanted to talk about it, how I dealt with problems I've encountered. And I'll introduce local first and then show you how you can use the concepts of local first development to solve some of your problems as well. A little bit about me. I was introduced, I'll just note that I'm also writing at Medium, so if you like to read some of my stuff, I love the feedback, so please do. So, I think that classical web applications are still using mostly the same pattern of request and response that was always been around, right? Give me the data, here's your data, give me another chunk of data, here's your data. User is doing something along the way, changing maybe, and then save me the data. Data is saved or not, depends on the case, which is working fine in many use cases, but when there are lots of users that are working on the same data, same information, things can go wrong, right? Think about, even in simple use cases, online shopping, right? Everybody's doing online shopping. And if I'm looking at some item and he's looking at the same item and there's like one in stock, one of us is going to be disappointed, right? Discovering maybe too late that the item is no longer in stock, right? The next time the website will do this request response cycle. Maybe a more common use case is where the number of items, let's call it, or is limited. Think about booking plane seats, right? There aren't many good seats in a plane or in a concert, right? Or at the cinema. So many users are competing on the same spots. And if the website is not doing some live updates using WebSockets or different technology, then people will discover too late that those seats, etc., are not available. So let me ask you a question. Who's in here? I hope I can see you because the lights are like strong. Who is using WebSockets in production for live updates? Okay, I see 3 hands, which is like, I don't know, 2 or 3% of the people here. Not enough. So I guess all the rest, when working on web applications, are doing the same old cycle, which can be an issue, as I've just said. And managing cache in such scenarios where many users are accessing the same data can be a problem as well. Let's think about a large concert. Let's say, I don't know, Taylor Swift is coming to Serbia and opening a website for tickets. So I guess, I don't know, 100,000, 200,000 Swifties are will try to buy the tickets, and it won't be a good idea to select and query all the available seats all the time from the database, right? So you probably want to use some kind of caching, but this is not a read-only cache, right? Because people are buying tickets and selecting seats all the time, so you have to manage that, which can be a problem with this amount of updates. So that's another issue I've encountered. And the last one, but not least, is being offline. I started investigating this issue when a new project came into my company, and it involved field engineers. And when I talked to them, I was surprised to discover that in many cases during the work, they are either offline with no internet connection or limited connection. They're at remote construction sites or underground, etc. And it was surprising to me because I'm sitting in my office all day with high bandwidth and continuous internet connection. But maybe I'm the exception, right? Maybe there are a lot of cases, and I found a few. Let's see. Underground, right? Trains, etc. At sea or on planes, right? Although you can pay a lot to get a satellite connection when you're in an airplane, we usually don't, right? So we're out of sync. Even if you're not underground, going through tunnels, at occasions with lots of people. I mean, I guess even here it's a little bit of a problem. I noticed the internet here was a bit slow, probably due to the number of people, but think about thousands or tens of thousands of people working against the same lousy cellular antenna and trying to be online. So this can be an issue as well. This green is very nice, but probably no antenna close. Bad weather, I can go on and on. Natural disasters, third world countries don't have reliable connection. Accidents happen, and I couldn't not mention, thanks to the guys that brought me here. Just 2 weeks ago, right, we had the Amazon outage. I don't know if you experienced that in person, but look at the headlines, real headlines I copy-pasted from some online papers. Took down the internet, right? Took everything down from banks to smart bed, and it was a very large outage. And although AWS tried to explain it was a bug in the automation software, nobody cares, right? Because the users that couldn't work against their banks or operate their smart bed was upset. So it happens. It happened before, even to Microsoft with Azure and with Google's cloud. It now happened to AWS, and it will happen again. So if we want to give a full and continuous experience to the user, we have to think and come up with solutions. And this is another use case, right? These guys are gaming together. I don't know why ChatGPT made them so angry. Maybe it was during the AWS outage. And the more common case is working together, right? These two are working at a sheet of paper, but you know that today working remotely is more and more common. So collaborating and applications like Figma or Google Docs and many other applications are helping you collaborate and doing the online synchronization between clients. So these are valid use cases that you either encountered, maybe dealt with it with the WebSocket, the guys that mentioned it, and maybe you'll encounter that in the future. And in short, you'll have to do these things yourself, right? Keeping the browsers of the users synced together, right? Stale data. What happens if I'm changing information and you're seeing a stale copy that is not updated, managing the cache and handling the offline times. But it doesn't have to be this way. We can easily imagine a better world, right? Where everything is done automatically for us, starting for the applications that can work offline in a transparent way without you making any effort, handling the cache, resolving data conflicts automatically, syncing the database if you write to a local database, and enjoy the improved performance that comes with local databases that don't go and instead of going to the server. And I think you know the answer if you remember the title of the session. Local first, right? That's our topic. And when I investigated, I found, I think this is the first academic or semi-academic article that talked about it. It was actually a few years ago. It was in 2019. And they introduced the concept. Actually, they're not talking about real implementation. It's a vision or a conceptual thing. They have like 25 pages of why they're doing it, and they're defining 7 ideas or 7 ideals for handling with local first. If you're interested, you can read it later. Actually, it's quite interesting. But my point is that there is a concept behind it. They're talking about owning your data. They're taking it to the extreme, not just working offline or syncing users. And they're talking about owning the data. And one of the ideas is that the data should be yours forever and not just save it in some server. And I'm not talking about this ideal, but take you to the more practical side of the concept, but know that there is a wider idea behind it, right? So it's always better to know the intentions of the creator or how things roll out to the present, but we're not going to dive into that, right? So instead of the request response that we used to, I'm talking about a better option. Let's start talking about implementing those ideas. So we can imagine a local database that will be on the client side. And what do we gain for that? We can, for example, work faster, right? We have the database closer to us. We can work offline. We're not dependent on the server. But you know that it's not enough, right? You can't be isolated from the actual server. So we'll have to sync, and we want things to be done automatically, right? So we don't want to work hard. We can aspire to that. And again, the idea behind that is to make things different from how we thought about websites until now, right? It helps. You can still keep the old way in mind because we're not always creating new application from scratch, right? In many cases, we are improving or adding to existing websites. So we have to take that into consideration. But the state of mind is having your data local first thing and the ownership of the data. So with this concept in mind, we can start making some action. Right? In general, there are 4 stages that you can do. First of all, fetching all the data to the client. Now, this is not always practical, right? So I'm saying all the relevant data, all the data that will allow operation, right? And I mean offline operation as well. We can bring items catalogs, for example, or specific user history. Anything that will help us or help the user walk offline if something happens. And it's not just that. Every operation will be done faster, right? Because it will be done against this local database, and the user will get immediate response. You wouldn't have to wait for the server that can be down, with no connection, or simply busy. And as a bonus, we're taking load off of the server, right? Instead of banging it with millions of requests, some of the requests are created locally, and we can always send them a bit later when the server is more available, right? So we'll have this local DB and we'll change, and I'll maybe revise this ASAP when it's most suitable, right? And as you can imagine, if we have multiple users working on the same data, we're bound to have collisions along the way. But today there are smart data structures and algorithms to resolve collisions, and I don't mean the naive way of resolving, of writing whoever writes last override the previous writings, because this is not always the correct result. If you think about, for example, a comment field, users are adding comments for some field. You don't want them to override one another. You want to concatenate the comments, right? Same goes for numbers. Sometimes you might want to accumulate the numbers that users are sending and not overriding one another. So you have quite a few data types that can handle these scenarios. This is a topic for a session or a seminar, but if you're not familiar with the term, again, I recommend diving in. But usually when you use some libraries, and we'll see that later, these are done for you. But of course, you can, as a user, define the correct behavior, the policy of merging, colliding information. So you're safe in that department as well. So when you do that, you gain a few things, not only in the user experience area, and things are more responsive. And when I did that, I found out that the website is much faster. You also get better developer experience. We'll see that when you use libraries, and there are a lot of libraries, we'll review some in a few moments. You're writing less boilerplate, you're writing faster. And by the way, if you use AI to write your application, it will probably not use this library because they're doing their code generation statistically. And statistically, most of the code is still using the old patterns of request and response. So you have to guide your favorite AI agent to generate the code using some library or some architecture that you desire. And I emphasize this sentence because after 20 years, I know that one of the most important things to do if you want your startup to succeed or project to succeed is focus on the business. It's so cool to write libraries like that auto-sync users across databases and sites. But if it's not your business, it's, I don't want to say a waste of time, but a waste of your business time. You can do it as a side project or as an open source project. But in order for something to succeed with all the distractions we have all the time, it's just focusing. So if you're using this approach, use as much third-party code as possible. Don't try to implement these ideas yourself, unless it's, again, an open source project. And focus on the business, and things will be much faster and fun to develop. I can promise you that. For example, instead of doing the common fetch where you handle the URL and deserializing and setting the state with the data and handling errors. And did I forget anything? Yeah, maybe validation, handling the loading icon and caching, etc. You can do it much faster with some library. For example, Convex, and this is just one example. I'm not related to Convex in any way. And besides the shorter code and the smaller code base, you get a lot of benefits as well when using such a library that, remember, connected to some database in the background. Since it knows the database structure, you can get a type-safe data structure and type checkings. It's automatically connected to your client, usually with WebSocket. I don't know if the guys that raised their hand did it themselves or used some library, but it's not always easy and straightforward, so it's done for you. Caching, again, for all the clients. If someone changing something, the cache is updated accordingly, and all the changes are pushed to all the clients. So everyone is updated. And if some reads are constructed from several queries, it is the library's responsibility to keep everything consistent, even though there can be some updates to the same data at different times. And let's say the visible effect of using such a library is that everything is synchronizing. Right? If you add one product to your cart, the number of remaining items is updated accordingly. But although you can achieve that in several ways, it's not just messaging a different component in your browser, right? It is being synchronized with all the users that are using your application. So it's in a much larger scale, and we want that. It doesn't have to be fetch, even an updating operation like delete, for example, you have to, again, send data to the command to the server and get the answer, update your data structure, even if it's reactive and the UI is changing, you still have to set the data behind, handling error, etc. Instead, you can just define a mutation in one place and use it, gaining all these benefits for free. So, how can you achieve that in an easy way? I'll start and say that there are many libraries out there, and you don't have to go all the way at first. Again, and I said that, and I'll say that again at the end, you don't need to implement these things yourself. They can be hard to do it in an accurate way. It's composed of several modules, so I don't recommend doing it alone, again, only as a side project. But let's start at the easiest part. Again, you don't have to go the full scale. Sometimes you don't need to, right? So you can do one part, and an example of such a solution is using an in-browser database, right? And if you're wondering what you're going to gain from that, as I said before, queries will be faster. Remember that the first step is to bring relevant data to the client, and you can work offline, right? But it's not syncing anything to the backend. You have to do that yourself. But in some cases, this solution is enough for you. And as you can see, there are a lot of databases you can use. People that implemented in-browser database for such cases and other use cases. So there are use cases for that. You have the built-in IndexedDB, which is also persistent in the client side, and a lot of other. These are just a few examples, varying in different aspects. Some are more on the SQLite side, and some are implementing Postgres in the client side. You can even use analytical DB if you want. And Tinybase is reactive. I think that all of them have the option to persist the data, and they actually use IndexedDB behind. So if you use them, you won't lose the data. So you can start small. But if you don't want to start small and add, maybe try a different angle, you can use a synchronizing database, or to be more accurate, these are layers on top of a database that handle the synchronization. And in this case, you'll gain the UI syncing with other users' action automatically for you. And these databases can scale very high, so you don't have to worry about a lot of users and a lot of connections. There are a lot of examples here as well. And let's take Supabase, for example. Anyone here is using Supabase? You're using WebSockets as well, right? You're the same person. Okay, so you're a very reactive person. So Supabase is actually Postgres wrapped up as a SaaS service, but as a bonus, you're getting the syncing ability. So we can look at this table, and I've created with Lovable 2 pages. One of them is actually showing the information, one is updating. And if you see the code executor here, I'll change it to something else. And actually changed here to runner. I'll put it back. Let's make it a different thing. And it changes automatically as well. Interesting to say that the UI of Supabase is not reactive, right? I don't know why they choose that option to be their default, but if I'll refresh it, the database actually changes. And it does work on the other direction, right? If I'm changing stuff from this GUI, my client that is updating sees the changes here as well. And it's fast and it's easy, and I didn't do anything special. Actually, I didn't do anything at all because Lovable wrote it for me, but it uses the Supabase JS library, and with one command it can create updating queries. So these are the syncing databases. Or we can go the whole way and actually gain all of the benefits. In this sketch, you can see that we have the client database, so we can be local first and work offline and work fast, etc. And we have the synchronizing database in the backend that actually sync between users. So if you go with this configuration, you'll have everything. And there are a lot of databases that give you that as well. And I used Electric, which is open source and working against Postgres. And you can easily try it. Sorry. This one. Okay, you can start it easily and play with it, which I recommend that you do. It has a Docker Compose that starts actually 2 servers. One of them is the Postgres to play with, and the other layer above it is the Electric. And what happens on startup is that Electric is what they call electrifying the database, adding triggers and function to monitor all of your tables so it can detect changes and propagate them accordingly. So all of that is done for you, actually. And if we take a look at a sample page, it's connecting to the Electric layer of the stuff, not to the database, and gets what they call shape of some table. Shape is the view that you see. And the table name is scores, just a simple table. And you can see that this is actually connecting directly to Electric and see the data with some additional metadata. But if I want to look just at the data, we can change it the same way we did with Supabase, just locally, right? So if we set the number 2, it's now James to Bob. It changed almost immediately. Let's try another thing. Let's duplicate that. Right, so they're both Bob now. I hope you can see it clear enough. Yeah. And let's update it again, and both of them are updated. So it's fast. It's easy. The code is pretty simple, right? So you get a lot for free and can use the entire library for free. Of course, you see that there are a lot of options here, and these are just some companies that are using the ideas of sync engines. But these options vary with the amount of features that you get and the complexity of the solution. Of course, the high-end frameworks are not always free, but I used Electric and it was easy and answer all of our needs. And if you wonder how you can choose wisely, if you want to actually start play with it, there's the nice people have created this website with a lot of options and a lot of features, and they're making this great matrix for comparison. Let's look at the tiny base. You can get a lot of information about this product even before trying it, so you can narrow down your option and choose wisely for the right use case. Right? Again, not every use case needs the full syncing engine, and it depends if you're using a new application or extending an existing one. Right? So you can check that, and it will help you decide. So just another support for using a sync engine. Again, easy life. Okay, so to summarize, we've heard about the problems that you might encounter in some use cases of multiple users updating the same data. talk about the concept of local first and show you some options how to use it in various architectures. I hope you liked it. And again, this is just the tip of the iceberg. That's the introduction. There's a lot to dive into. You can't do that in 30 minutes, but I hope that you like the concept and you'll actually use it. And if you have any questions, you can ask me now or later on. Thank you for listening.
So we have enough time for questions, so now you should ask. And of course, if you don't want to write into your application, you can just, raise your hand and we'll give you a microphone. Oh, right here.
Well, some aspect will help. Again, working offline at this case is not useful, but updating all of the clients and managing the cache will enable the Swifties to see the actual availability of tickets and seats in a concert. Things will be updated online, and they won't be disappointed that they'll mark this seat in the close to the ring, and then finding out later on that it's not available, which happens a lot because I've encountered many ticket ordering websites that are a bit older and not working with live updates. So it will happen this angle. Working offline in this case is maybe not practical. So again, like I said, you can take some of the concepts and libraries that implement part of these ideas, and I'm very practical. Although I am again recommending reading the article and getting grasp of the full vision of the authors.
Thank you. We have another question right here.
I have a question. Do you have actually any benefit if we're using local first for better user experience and offline mode? And can we utilize somehow Superbase for that use cases or convex?
To tell you about the use case, like I said at the beginning, we had to build an application for field engineers that they're adding some data. And again, they had limited connectivity at some point. So this enabled them to work offline, even if they weren't connected. They could still key in the information about the construction side. They had to do some reporting using this application. And again, better using experience, even when they are online, when you write locally to a database, instead of waiting for a server, and it doesn't matter if it's online or not, it's faster. They have like an instant user experience.
Yeah, just to clarify something, if you don't have multi-user support, is that really important to have something as convex, or can you use simple SQLite on the device?
If you don't have to sync between users, you can go to simpler solution. Again, I always say just solve your problem. Don't go to the full scale at the beginning. If you just want to work offline, you can use what I saw, the first configuration, just a local database. And you can even use the built-in IndexedDB, all browsers are supporting it.
Okay, thanks for that.
Thank you. Now we have a couple from the application. How does electrifying Postgres work in high throughput scenarios? Example, lot.
They have full support for scaling. You can, Electric has what they call a syncing node, which is actually the layer that's sitting above Postgres. And you can have multiple syncing nodes that they are stateless, but they all connected to the database, and you can shard your database or do vertical scaling the same way you do without Electric. And those syncing nodes will again sync their client according to what's happening in the database below. Like I mentioned, they install triggers and function to update and, by the way, resolve all the conflicts with CRDTs, as I mentioned, for you automatically. So there are, at least Electric is the library I'm most familiar with. They can work in large scale.
Thank you. Another question, how to perform massive migration in local DBS if we want to add new field into inventory table with one MLN records, how to recover corrupted DBS?
I didn't get all that.
So how to perform massive migration in local DBS?
Yeah, talking about massive migration in local databases, if you want to add new field into inventory table, a specific table with one min record. I'm not sure what that means. How to recover corrupted database. Well, this is not related to local first specifically. So massive migration, there are a few schemes you can do. First of all, if you can, don't update while migrating. Use fast copy tools. Don't do it with SQL, but maybe copy the data files behind. There are various tactics to do that, but it's not really related to local first.
Thank you. That will be this for this session. So next is lunch break, and have a nice one. See you for the next.